Hello, I'm Nitin Dahad with EE Times and Embedded.com. I'm here with Sally Ward-Foxton with EE Times. Hello, Sally.
Hi, Nitin.
We're here at the Design Automation Conference. It's the 60th one in San Francisco here in the Moscone Center. And we've been here for the first day, attending the keynotes and talked about all things design automation. Maybe I'll just give it a little bit of a kick-off. I went to the analyst presentation last night with Charles Shee of Needham, and he talked about various trends, obviously trends that impact and affect the EDA industry. And surprise, surprise, the big thing he talked about was the fall of general purpose computing and the rise of domain specific computing, which we've been writing about in EE Times and Embedded quite a lot.
It's all about AI, yeah, absolutely.
Yeah, and the keynote this morning, it was all about AI as well. But no, he talked about how designing a chip is becoming much more expensive and the fact that geopolitics are involved, so that doesn't help. So what's the result of that is the re-emergence of vertical integration. And and that means there's a great opportunity for EDA companies, surprise,
absolutely,
surprise.
yeah.
And the EDA industry, actually another fact that came out this morning, the EDA industry, electronic system design, it logged $4 billion in revenue in Q1 2023, according to the ESD Alliance. And Charles last night talked about double-digit growth in EDA and whether that can be sustained. So that was kind of interesting. But no, tell me a bit about the AI stuff that you saw today.
So right from the keynote this morning, we had Alberto Sangiovanni Vincentelli here giving the wonderful keynote. And one of the things he said was that, rather than call it AI at DAC, we should be calling it the AI Conference Applied to Design, because everything here, there's an AI thread through absolutely everything here, which of course is right up my street, as you'll know. So I've been visiting a few AI chip companies that are here. One of the ones I spoke to this afternoon was Esperanto. Esperanto have been around for a little while. They have this big RISC-V design with 1,000 cores on one chip. But
famous.
It's very, very famous in the world of RISC-V anyway. Since I last spoke to Esperanto, they kind of refocused a little bit as the market's changed. The chip is very well set up actually for generative AI and for LLMs, so inference at scale is really absolutely what they're all about. So I think it was really nice to catch up and see how they're adapting to this new market.
And it's actually, Mike Ello of Siemens in the visionary talk this morning. So what they're doing at DAC is visionary talks every morning and then a keynote talk. So Mike did the visionary talk from Siemens, and he talked about how AI everywhere will drive increased semiconductor consumption. So, and I like this sort of triumvirate of statements. So while software is eating the world, software is eating the world, hardware is enabling it and data is driving it. And it's, I think I've got that wrong, but it's around that.
Hardware is feeding it and data is driving it.
That's right. So he talked about it's all around enabling that is going to be all around multi-domain system knowledge. And that's going to be a big issue. So I think companies that you've been talking to, they're going up and having that multi-domain system knowledge. And he talked about specialized workloads, will need matching hardware to enable key KPIs, and that will therefore need digital twins to experiment and optimize. And I won't go into that, but there's a lot around digital transformation, digital twins, all the people I've spoken to today. Any thoughts?
Yeah, absolutely. I think digital twins are going to be so important, and there's such a big crossover with AI that it's it's another really big theme here.
I think Alberto Sangiovanni Vincentelli basically talked about the complexity of AI, and it will need multi-physics design everywhere. And how do you use that in AI and ML in EDA? And interesting enough, he said what most of us think anyway, that we've all been doing AI for a while. It's the machine learning and the specifics of that that's actually taking off now, and the compute power that's available.
That's enabling it all,
Exactly. But he also talked about the evolution of 3D ICs, and that's probably the biggest thing in the sort of design and design automation space that actually is going to impact how we go forward.
It's a really big challenge. I think people are seeing solutions, but there's a lot of big challenges around implementation, especially for EDA companies and so on. So it's another huge theme here at the show.
And one of the things I think I got from Alberto's talk was that the scarce resource of the future, and we all talked about data being the new oil, but now it's going to be talent.
Talent is the new oil. Yeah. Okay.
So I don't know if you picked that up.
I did actually, and some of the companies I've been speaking to that are using AI for chip design, it's all about not minimizing, but getting away with as little talent as you actually need, as few engineers as you need to make the same design or to make a better design with fewer engineers. It's a really strong theme again, yeah.
Yeah, and I actually, that's a good point. I had a briefing with Cadence today, but their thing is embargoed till Thursday.
We'll tell you then. We'll
tell you
then
on Thursday.
Yeah.
But I think they're talking about how some of these tools make it easier for people without the talent as well.
Okay.
So it's quite interesting. What else did you see today?
So I saw another couple of chip companies actually. So Polyn is one that I have never spoken to before. They're the absolute opposite end of the scale from Esperanto, like from one to the other. This is for really, really tiny little analog chips, and it basically runs this analog neural network.
Is that the NASP?
The NASP.
Yeah.
So basically, it's about reducing the amount of data. It's like pre-processing using AI, so reducing the amount of data that you need to send to the digital chip. But you can do it in like 100 microwatts or something.
Yeah.
It's an interesting design. I've never seen one that's actually fully like fixed function for AI before. There's no programmability in it whatsoever. It literally is application specific for that exact neural network. But yeah, if you can do it in 100 microwatts, you don't need this. If you don't need the programmability, there's a lot less overhead. So the power consumption can be a lot less. Can be very, very efficient way of doing it. So that was very interesting.
No, I actually did a piece on them this morning as well. So
there you go.
But not here because they're also presenting at Hardware Pioneers Max this week in London.
Oh, in London. Okay. Sorry to miss it. Yeah. So. Hello, everyone in London. Yeah.
Yes. Yes, they are, and we're also there with our colleagues. I think that's very interesting. I saw a company called Weebit Nano.
Oh yes.
And,
okay.
I'm sure you've spoken to them before, but the CEO there was telling me about how their business model, but also how they've sort of qualified with Skywater, and how ReRAM is going to be better than Flash. I think you'd expect that to be, but I think in terms of being able to do more edge AI stuff, and I think that's where his play was, but also in automotive.
Yeah, cool. Sounds cool.
Yeah, and I also saw Keysight, and what I didn't actually know a lot about before, because I always thought of them as a test and measurement company, is their EDA business and the software business. So they're actually using using and designing and using their own tools for RF design.
Oh, that's interesting.
So that's a big part of their business. So he gave me some figures, and it's quite a large proportion of their business. So they talked about applying AI and ML for steps in the process for RF design.
Yeah.
And again, the key theme for all of the companies I've met is around interoperability and sharing of data, and how do you do that across multi-domains.
Okay. Okay. Yeah. Very important. Also very important.
So that's what else? Anything else?
One last one I wanted to mention, which is Applied Brain Research. I've never met them before, but they've been around for quite a long time, this company actually. Very, very interesting company. So they started out doing software that was running on Intel Loihi. But of course, Intel Loihi was never commercialized, so they've had to change direction a little bit. They've invented a new kind of neural network, which is super, super cool. It sounds great. It's all about basically compressing the data and then running the neural network on the compressed data, the representation of that data, which is how they make it a lot more efficient. So, they have designs on NLP, LLM type. They're going in that direction. But they have hardware coming soon that is designed especially for this special neural network that they've got. But I think they plan to tape out towards the end of the year, so it's definitely one that I'll be keeping an eye on.
You certainly should. For me, the overall theme for so far, today and last night was around digital transformation. Everybody talks about that, still talking about it. But then domain-specific computing, and vertical integration. All the OEMs and the system companies are now becoming their own everything. And lack of talent, and I think that's the key thing.
Talent shortage rather than lack of talent.
Talent shortage, yes, that's right. That's absolutely right. So tomorrow, I'm going to be moderating a panel on designing effective autonomous systems and digital twins. So that's at 10:30 this morning for any of you who are watching this, and also going to be at the conference. And you're doing Not tomorrow, but Wednesday, aren't
Yeah,
you?
Wednesday I have a presentation around 10:15 in the morning, which is all about different types of AI chip architectures. Very exciting. I'll be presenting with analyst Ian Cotras. I have 2 panels also on Wednesday that you should definitely check out. One's about AI chip architectures, different types of architectures, and the other one's about chiplets and computing at scale. So if you're interested in that, that's Wednesday afternoon as well.
Well, great. Well, we'll see you again tomorrow. And this is me, Nitin Dahad, signing out. And
Sally Ward-Foxton with EE Times.
thank you.